Hello, everyone. My name is Cindy Sheng, and I'm going to share with you today our work investigating how viewers synthesize conflicting information from data visualizations. Science, I believe we all agree, is quite important in our lives. To make scientific knowledge accessible, engaging, and memorable, scientists and journalists leverage data visualizations and news articles to turn scientific findings into easy-to-digest summaries highlighting key takeaways. However, scientific progress can be incremental, and it's common for subsequent work to offer contradictory results. For example, imagine deciding whether you should keep drinking coffee or not. Your internet search yields two results. One source telling you that drinking coffee is good for your health, and another source saying that it's bad for your health. Now, what are you going to do? Should you keep drinking coffee? Scientists often write reviews of existing work by carefully assessing evidence, making comparisons, and building connections across studies. We have all written or read a background section here or there where the researchers offer systematic reviews to help both themselves and the readers synthesize existing findings. However, general audiences reading articles online are likely not equipped with the commitment or resources to conduct such systematic, rigorous reviews or synthesis. So we conducted a survey asking crowd workers what they would do when they come across conflicting pieces of evidence. And this is what we found. Note that one person may fall into multiple categories. Most people will keep searching. This one participant wrote, I continue doing more research until I can find what the truth is, or at least which side is more favored. Some will evaluate the quality of the evidence they find. This participant wrote, I try to evaluate which source of information is the most trustworthy, and then try to see if any other reliable sources have recreated a certain piece of evidence. I want to know about the veracity of each side before deciding which to believe. Some will even compare information across multiple sources. This participant wrote, I consider each separately and try to see if there is a connection or some part that corresponds to each other, then look at the differences. However, some will rely on their gut instinct or common sense, and some will seek out information that validates their beliefs. And you can see all these strategies can be subjected to cognitive biases, such as satisfaction or search bias, confirmation bias, recency effects, among many others. So to mitigate these biases, we should think about building tools or presenting information in ways that empower people to more effectively synthesize information, so they can better understand the risks behind their decisions. But before that, we need to investigate the underlying cognitive mechanisms behind how people synthesize information. This will allow us to build a model around potential systematic biases in people's information synthesis behaviors and inform our design of tools to assess information seeking and synthesis. Towards this goal, we conducted a series of experiments where we asked participants to synthesize information and report their mental representation of the information. The results reveal systematic biases in our information synthesis behaviors. Let's experience the experiments. Let's say you're interested in the relationship between X and Y. After an online search, you find a reputable research institution producing this chart, which shows a negative relationship between X and Y. Just to be sure, you dug a little deeper, but to your surprise, you found this other chart from an equally reputable research institution showing a positive relationship between X and Y. Now, what do you think the relationship between X and Y really looks like? Try to draw a mental line. Maybe it's this, or this. Participants were asked to synthesize the two pieces of information and use an arrow key controlled drawing widget to draw a line. And this is the average line they drew. And here are the information they synthesized for reference. This gray line shows you the mathematical mean of the two slopes. So if you weigh the two pieces of evidence equally and can do math perfectly, you should be drawing this gray line. In addition to drawing a line, we also asked participants to estimate the y value when x equals 20 and when x equals 80. In this case, we would obtain 2 points from the response, which we connect to make a line slope, which I will refer to as the verbal synthesis response. We can compare the two response elicitation methods to the mathematical average to see that both measures elicited quite similar responses that deviated from the mathematical mean. So let's bring back the stimuli for comparison. Just a reminder, this is the first chart people saw representing findings from institution A, and this is the second chart people saw. So what is happening here? Participants seems to be biased to see the slope as more positive than the mathematical average of the two slopes. Of course, the result is obtained after counterbalancing the order of the charts that are shown to people. So from now on, let's just refer to them as chart 1 and chart 2. We sampled a few variations of slopes, where both slopes are shown in the opposite direction, one positive and one negative. And across the board, the participants' response synthesizing the two slopes is biased towards a positive slope. It might be a little hard to see the bias towards the positive slope, since we know from the perception literature that angles are not the most accurate encoding channel. So let's visualize the result in a different way. Instead of showing our results using angles, I will show them via position encoding. I'll use the top one as an example. I'll plot the slope value on this number line here, and the slope of the positive line will be plotted here, and the slope of the negative line will be plotted here. The mathematical average slope would be put right here, and the drawing response goes here. Finally, the verbal response goes here. So creating some shorthanded note for these, I'll move this to the top right corner and show you the results for the other conditions. Here they are. We tested some other combinations of slopes as well, and to obtain a summary result that is comparable across all conditions and both response modalities, we'll normalize these results so that the relative negative slope can line up, as well as the positive slope. So we will average across the two response modalities, combining drawing and verbal responses, cleaning it up a bit, and this is what we get. When two slopes were shown in the opposite direction, people synthesized slope is biased towards the positive slope. So far, the results we have shown are from the experiment where the x and the y-axes are labeled with abstract variables x and y. We conducted an experiment too, which gives the charts more context by labeling it with more realistic variables. We tested two scenarios, one about water usage and crop yield, and another one about the quality of life and government public spending. And here are the results. We find the same patterns. We tried a fourth manipulation where we put descriptive text surrounding the charts, and again found very similar results. So now your brain might want to synthesize this information I just presented you, but you become worried about the potential biases in your information synthesis. And you realize that all these results are quite similar, and I've only showed what happens when people need to synthesize information that are inconsistent from each other. So you may be wondering, how do we synthesize information when the two charts are showing more consistent results? Which I can translate to, what if the slopes shown are in the same direction? In this case, they can be both positive or both negative. When both slopes are negative, instead of plotting the negative slope on the left and the positive slope on the right, I will plot the stronger slope on the left and the weaker slope on the right. The red line shows average participant response. This is the result for when the charts are labeled with X and Y. And here are the results for when the charts are labeled with real-world variables, water and yield, and public spending and life quality, either as a standalone chart or with surrounding text. Again, you see that the results are quite consistent across these conditions. So when both slopes are negative, participants' synthesized slopes are biased towards the weaker slope. They think the synthesized slope more closely resembles the weaker slope. When both slopes are positive, after normalizing the slopes and responses following the same setup as the negative slopes, you can see that the results look very similar. Here are the results for the rest of the experiments with the two positive slopes. So we see the same bias. Participants think the synthesized slope more closely resembles the weaker slope when both slopes are positive. So this effect also seems stronger when the slopes are both negative compared to when the slopes are both positive. These findings supplement the previous conditions where participants see opposite slopes and they were biased towards the positive slope. And here we have a summary of the key takeaways of this work. Future work should dig further on why we are seeing these biases, their implications, and how we might use these results to inform tool design to assist information seeking and synthesis. That's all I have. Thank you very much.